So today we're going to go over a little bit of TensorFlow and machine learning. We're actually going to try to build our first model, and we're going to go through and actually build a spam classifier that we can use for our mobile phones. So we're going to go ahead, we're going to go over some TensorFlow concepts. We're going to build our first model, and we're going to lightly deploy it to an Android app. Dan has a talk right after this where he'll actually go more in depth into actually running a model on your phone. So what is machine learning? In a nutshell, machine learning or ML is a field that gives computers the ability to learn without being explicitly programmed. So if you think of an example of this, you could look at a translation service like Google Translate. Maybe you want to create a program that can translate from English to Spanish, and you might go buy an English to Spanish dictionary, and you might do a one-to-one mapping of an English word to a Spanish word. That's not going to really work. You're going to run into a bunch of grammatical errors and other things that just don't actually work in the long run. So then you can go in and you can actually program every grammatical feature of a model, and that's really tedious. You have to stay up to date with slang and other things like that. But with machine learning, you actually don't have to understand English or Spanish as long as you have the right data set. You're going to hear me talk about that a lot today, is that the data set is the most crucial part when you're going to go out and actually build a model. So if you have two translations, you have an English, let's say a book, you have all the copy in English and you have all the copy in Spanish, you can actually train a model between the two to easily translate between them. It makes things a lot easier in the long run. So what kind of libraries would you end up using for this? There's a couple popular libraries that already exist. Scikit-learn is very popular. It's a very easy way to get started into ML. It has nice visualization tools and things like that. You may have heard of CoreML that was recently released. CoreML is actually a wrapper around two existing libraries that were already released by Apple. We'll also, the concept of this talk, we'll talk about TensorFlow. TensorFlow has gotten a lot of traction recently as it was recently released by Google. And a little bit of random info with these ML libraries too. If you actually want to run this on your phone, you're not going to train a model on your phone. The hardware is just not there yet. A lot of times you're going to do what's called inference, which you're going to have a pre-trained model that you're going to go ahead and you're going to run against it on the phone, and you're going to see what happens. You'll actually find out that when training a model for the first time, you always want to have access to a GPU. GPUs are usually faster. But when you're doing inference, a lot of times CPUs are actually faster. So this is a benefit for us on mobile phones where accessing GPUs is still kind of hard to do and not necessarily as easy and straightforward as it is on like a developer machine or something like that. Some examples of machine learning that you can do or that is currently being done on mobile is you see a lot of stuff with vision. You can take a photo and we can tell you what's in it. You're seeing a lot of things with natural language processing such as spam detectors. If you use Gmail and you see the auto reply feature, that's actually an example of natural language processing. You might see some game AI stuff. There's a lot of examples recently where people are training models to go ahead and beat popular games like Super Mario and things like that. Then a lot of times too, you'll see speech recognition and generation. You'll feed a model a bunch of examples of different characters and things like that, like O and A over and over and over, and eventually a model can actually figure out how to do speech. A good example of this too is if you have a data set or you're having trouble getting one, you may find that you can actually use models in different ways to actually get there in the long run. So this is a photo I took on Saturday of Central Park. If we wanted to train a model to actually detect landmarks, you might find that going and taking 1,000 photos of every landmark is pretty tedious, and it would require a lot of work to program each new landmark into the computer. But what if we split this photo up into 4 different sections? It could be 8, could be 16, we're just going to go with 4. There's a lot of models that are already pre-trained that exist that can tell you the dominant object that exists in an image. So if we run those through, we can see what exists in this model. We can see in the top left, we see trees, we see skies, we see statues. We see people and fountains on the bottom left, and on the right we also see that it thinks it's a ballpark, it thinks it's pavements, it thinks it's crowds. Well, then you can feed this into a second model that, given descriptors, can figure out what kind of landmark it is. So in this case, the model could figure out it was Central Park. It's a lot easier to come up with 1,000 descriptors of landmarks than it is to build 1,000 photos. If you actually wanted to go and build a model yourself, the most important thing first, it sounds silly, but you always need a data set. That's kind of the hard part, I think, when building a model, is finding good data that you can actually work with and manipulate. The second part, you might do normalization and or cleanup of data. You'll hear this concept about whales. I used to work with a product manager who worked at Zynga, and he had a famous story about they would run these A/B experiments, and they would look really positive, they'd look really great. And when they'd actually go down and analyze the data, they'd realize it was just a couple users, maybe 2 or 3, that were just buying these in-app purchases. And it was actually worse for their core users. So these whales were essentially data that was way outside the norm that they needed to remove in order to make their model actually something that they could work with. You'll usually define hyperparameters or tuning knobs. These are usually just variables that you set, like learning rate and stuff like that. You'll build and create your graph. So this is something that's specific more to TensorFlow. So we'll dive a little bit more into that later about what a graph actually is, how you go and define it, and operations and things like that. You'll run or fit your model. So you'll go ahead and do that. And then lastly, you'll validate it. So if you have, let's say, 5,000 items that you can build your model off of, you might want to save 500 items at the end to sort of validate and see if your model is successful or not. So this is actually an example of a graph. So this is a model that's been pre-trained to detect spam. And you can go through and you can see on this graph, there's a bunch of nodes. The nodes are what you'll usually define in TensorFlow. Each node itself might have a bunch of operations. Operations can be something as simple as adding 2 numbers together or multiplying them, or something much more complex. In the end run, though, everything will take an input tensor and an output tensor. So you can go here and you can see these are 2 nodes that are talking to each other. You can see input data. This is what we're actually going to feed it. So in the case, this would be like the message body to detect whether or not it was spam. You'll see a second layer, which is the fully connected layer. This is a layer that allows us to, over iterations, start actually programming and seeing what's going on and run it against data that it saw before. If you dive into an operation, you'll actually get a little bit more of the actual things that are going on. So in this case, we can see we're running argmax against 2 inputs. We're equaling them, we're doing a cast, and then we're running the mean. The mean is the actual output we get at the end to determine whether or not it's spam. So then what's a tensor if every operation takes an input and an output of a tensor? Tensors are just simply put, are just how data is represented in TensorFlow. They're multi-dimensional arrays. In a way, if you were to look back at that first example of this, you could see our tensors are flowing through these different operations, hence the name TensorFlow. Another good example of a hyperparameter is a learning rate. If your learning rate's too big, our model might actually skip the optimal solution. If it's too small, you're going to need more iterations to actually get there. So this is a trade-off between time and actually having a successful model, or learning very quickly, but maybe the model isn't very good at what it's trying to do. For a lot of times starting out and building your own model, 0.01 is a good point to start. As you get into more advanced machine learning concepts and building your own model, you might want to play with this and try to do something a little better. For today, we're actually not going to use TensorFlow directly. We're going to use a framework on top of it called TF-Learn. So TF-Learn will make this really easy for us to get started. We're actually going to be able to build our spam detector in just 30 lines of Python code. And it makes it really easy. And how TF-Learn actually works is you define a set of layers, and it will go through and build your graph for you and connect everything. So this is our example app. I've been working on a text messaging app in my spare time, and a number that I recently got gets a ton of spam. So as you can see, it's just riddled with it, and we want to go through and try to clean some of this up. So this is a famous sort of like beginner example of natural language processing is hammer spam. So is our message spam or not? Luckily for us, a data set already exists. So we can go through and we can download this. This is what the data set looks like. There's basically 2 fields. There's ham on the left, and then there's the actual message body on the right. There's about, I think, 5,000 messages total that we have here that we can work with, which makes it a really good starting point for actually trying to train our model in the long run. There's still some things we need to do here. So if we actually go and look at this data and break it down to make it a little cleaner to read in a presentation, we can see this is what we have. So on the left, we have ham or spam, which is basically a range of 0 and 1. On the right, we have our actual message. This is great for us to read and for us to understand. This is not so great for machines. They can't really work with things like this very easily. So how do we convert our data to something that a machine can actually work with? Well, the left is pretty easy. A lot of you are probably already looking at it. It's just a Boolean, 0 or 1. We can go through and change that pretty quickly. But the message part is a little harder. How do you represent a bunch of words to a machine and that it can do mathematical operations with? This is a little bit harder to do and takes a little bit more work. What you'll use to do this is essentially a vocabulary processor. So if you just had two messages, I like dogs and I like cats, you could feed them into the vocabulary processor and it would output an array that was I like dogs, cats. It's basically just each unique word as they appear, and it assigns a numerical value for each word. You could easily represent this with a hash map. It's not very hard. This is probably something that a lot of you may even write for a lot of CS-style interview questions. Luckily for us, TF-Learn and TensorFlow have this built in for us, so we don't actually have to write this ourselves. We can go ahead and we can actually see a console output of what we have. You can see how it inputted, I inputted an array, I like cats, I like dogs. We actually got back an array from Python that had everything there. We can go through reverse is just basically getting what the number actually means in terms of words. So you can see that 3 is cats, 4 is dogs. You may wonder, well, what's 0 used for? 0 is basically reserved for any number that our model doesn't understand. It's basically unknown. We may need this later on. If you're running messages that your model's never seen before, it still needs a way to represent it, and that's what 0 does. At the top, you may notice for the vocabulary processor, I passed in the number 5. What is 5? Well, 5 is the maximum length that we want our data to be. So when you're passing your data into TensorFlow, you want everything to have the same size. You don't want, and messages can vary. Maybe some messages are 6 characters long or 3 words long. You can see in the example, both of our sentences were 3 words long. And since we put in 5, it added padding to the end. So it added 2 zeros. If our message was 6 or 7 words long, it would cut it off and only look at the first 5. So this just makes sure that all of our data in the long run is the same size. So now if we go and look at our data, this is a little harder for us to understand, but it's a lot easier for a machine to actually work with. So you can see plenty of numbers and things that we can actually run mathematical operations against. So now we get to dive into the actual part of like writing our model and seeing where that goes in the long run. So just to start off, this is a pretty easy statement. We'll just go ahead and import some common libraries. We'll import NumPy. NumPy is really popular for doing some mathematical operations on matrices. In this case, we actually need to do some manipulation with some multi-dimensional arrays we have, and we want to just go ahead and flatten them. We'll import TensorFlow and rename it to TF. So if you see TF, we're actually working with TensorFlow directly. We'll import TF-Learn. We'll need some operations that the string library has in Python, so we'll go ahead and check that in. And we'll also check in data utils has a special function called load CSV. So we can give it a CSV file, and it will output the appropriate data and labels that we'll actually want. So that's what we'll go ahead and actually use next, is we'll import our CSV file. So we already have the spam CS file already there. We're setting our target column to 0. So if we go back to the slide with our data, the target column 0 is ham or spam. This is what we care about. This is our labels. We'll go ahead and ignore the first row because that just has our definition in CSV. We don't actually care about that data. If you want to go ahead and actually see what data and labels is set to, we can go ahead and see it within terminal. So data is just this big multi-dimensional array. It's important to realize that it's a multi-dimensional array. We'll actually have to go through and change that. It's not just an array. It's not just a string array. We can go see the length. We have about 5,000 text messages. We can see the labels. So the labels are kind of interesting. What's going on there is it's basically whether or not the message is spam, and it's always the inverse. So the first message we have is not spam. We can go through and see what it is. And then we can also go in and we can see what the label for that is. So it's 1, 0. The second number in that array is whether or not it's spam. The first is just the inverse of that. We can also see it with our spam message. So we go through and can just see that it's the reverse of what the first one is. That's important for running our model. When we actually go and run our predict statements, we'll get two numbers back. And basically the second number is the spam score. The first number is the likelihood of it not being spam. Another thing that we need to do that's important is if you looked at our messages, there's a bunch of issues with it. People use punctuation, people use spaces. A lot of times early on when people were building early spam detectors, it was very easy to trick them because models would do things like if they saw the word meeting, there'd be a high likelihood that it wasn't spam. So if you wrote your spam message and then at the end of your message put a bunch of words like meetings over and over and over and over, it would think that it wasn't spam. So what we'll go ahead and do is we'll actually clean this up a bit. We'll go through and just convert everything to lowercase. We'll remove all the punctuation. We'll remove all of the digits if there's any digits in there. We don't care about phone numbers and text messages because those are probably unique to one message and they're not an indicator of whether or not it's actually spam. And then we'll also go ahead and remove any additional white spaces that might exist. So if they do a bunch of spaces in between words, we'll just convert it to a single space. If you want to see what our data looks like now, we can go ahead and output that. The first line is actually just converting everything into an array of strings rather than a multi-dimensional array. That's exactly what we want. We want to go ahead and remove the multi-dimensional array and just get a single array. And we're just going ahead and flattening that by the zero item. I wrote a definition that basically did everything that was in the previous line, where we're just going to go ahead and clean up the text. Now you can see that everything is lowercase, and it's in a way that we can actually work with. We remove some of the punctuation as well, all those dots and stuff that we don't need. So now we're going to actually build our bag of words. So remember I talked about before how messages that were a certain size, people would just spam it with message at the end of it. So we'll go ahead, that's what this max document length is, 20. We'll go ahead and cut messages that are longer than 20 words. We don't care. And we'll just go ahead and flatten that. We'll do our min word frequency, which is the amount of times a word should appear. So these two numbers are not necessarily optimal. This is just an easy example to show to build a spam detector. If you actually wanted to build something that was a lot more advanced, you might go and play around with these numbers and see how it changes your model. Then we'll go ahead and we'll put all of that into our train X value, and we'll go ahead and pass all of our labels of whether or not it's spam into our train Y value. This is basically, we're starting to actually build out a plot for our training data. And then the most important part is we'll actually build our neural network here. So we'll go ahead and we'll reset the default graph. This is just, we talked about before with the graph. We'll go ahead and just start from the beginning. We'll set up the first layer, which is our input data. So none that's being passed in there is just basically we're saying we don't have a variable length for this. It can be anything. The second is that max document length that we had before. This was 20. So we're letting it know that the tensor should always be a size of 20. We'll set up two additional layers. These are basically going to run against previous layers of the network, and they're going to work against previous iterations. If we remove these two, line 20 and line 21, our model would never actually learn anything. It would just always output the same result at the end. We need to run against previous iterations because we're actually trying to get a mean. Line 22, we're actually going to go in and remember we have two values that we're actually working with. So spam or not spam. That's what 2 is, and that's what softmax is. We're saying, hey, we need you to actually fit this into a 1 or 0. If it's not, you need to convert it to that. We'll build our regression layer, and then we'll actually go ahead and create our model from this. And then now we'll actually fit or basically train our model. So we'll pass it in. And luckily for us, this is actually pretty quick at running because we're not really doing anything super strenuous here. This only takes about like 12 seconds to run and go through. The nice part about TF-Learn is TF-Learn actually gives you this nice output. You don't necessarily get this for free. You'll see Atom on the left. That's their optimizer that TF-Learn uses by default. There's probably something better that we could use, but we're just sticking with the defaults for now. If we want to go ahead and run through, while that's running, we can start up Tensor Board. Tensor Board is basically a web interface that you can go through. And when you go there, you can actually see your graph. This is very nice. You can zoom in on each node and each operation and get what it's actually doing behind the scenes. So now that our models actually run and we have something we can work with, we should try to evaluate it. So I've set two messages already. I've set a message that's spam and a message that's not spam. We'll go ahead and feed this into our model and see what the output is. Word to vocab is basically just going to convert it into a series of numbers that we can work with. So the spam message had a 36% chance of being spam, which for our model is actually pretty high. The second message had a 0.09% chance of being spam. So this is pretty good. We could definitely improve this, but just starting out, we'll probably go ahead and use this and put this onto our Android app. We'll need to actually save our model. So this is actually not that hard. We'll just pass it a directory and the name that we want for the class. If we go and look at that directory, we can see 3 files. We'll get a checkpoint file, we'll get an index file, and a metadata file. These are not useful for running on a phone. We actually need a protobuf file. So what we'll do is TensorBoard has this script already for us that can go ahead and essentially freeze a model and output a protobuf model that we can run inference on. We'll no longer, once we freeze it, we'll no longer be able to train it anymore. But we already have those 3 files, so if we wanted to do that in Python, we could. So we'll go ahead and actually run that. And we'll go ahead and it will output the final operations into the graph. I won't really touch on this, but once you do that, it is important to import the protobuf file into TensorBoard. Go and find your input and output operations and just copy their name because you're going to need them later. If we look at the directory, we can see the frozen model is now outputted. This is a protobuf file. We'll take this file and put it directly into our Android app in the assets directory. And then if we actually go into some Kotlin code, we can see that it's actually pretty easy to work with our model from this point. The new TensorFlow library is actually a lot simpler than it used to be. So we can go through and we can run inference. So we can feed it the X value. So in this case, it's the float array or the message that we're trying to see whether or not it's spam. We can run it, and then we'll go ahead and fetch the output value. This will be outputted into the array at the end, and we can then go ahead and look at output 0. We're only outputting 1 value, and we can see whether or not it's greater than our spam qualifier. The spam qualifier is just a float. So in this case, it could be 0.3, I think was a good value to whether or not something was spam. If we rerun our Android app, we'll actually see now that we've gotten rid of all the spam messages and our app actually works really good. We could, for the benefit of the user, build like an additional tab that has all the spam messages so they could at least see them. That's not just lost to the ether. But for this example, this works fine. So that's pretty much it for actually going in and building a model and using TF-Learn to get there. All right, thanks.